Okay, this is section 7.5 called variation functions. We're going to talk about two different types of the way two variables can relate to each other. Okay, and this is what we call variation. If you were to, as you drive faster, how does your distance?
Increases.
It increases. The faster you drive, the increase, right? And you could also relate that if you kept your speed the same. Like you just said, we're just going to drive 60. But if you drove the longer hours, you would still go further, right? Okay. So when one number goes up and it affects the other number and it also goes up, this is what we call direct variation. Okay, now one of the most useful direct variation type of problems is distance equals rate times time. Okay, but I'll get to that in a minute. What we're going to talk about is what we call a constant of variation. All right, so if I say y varies directly with x. Some books say as, some say with x. What this means then is that we have an equation that says y equals kx. Okay? And this is called the constant of variation. Okay? And you can see that as y goes up, so does x. Or as x goes up, so does y, is probably the better way to say that. If this number remains the same, as this number goes up, this number goes up. And so on a graph, if we were to look at that on a graph, it would be a positive slope. And if one was going up, the other one would go up. One goes down, the other one goes down. You understand that? And so one of the most famous one is this one, d equals rt, distance equals rate times time. If we were to make one of these a constant, let's say we kept our rate the same, as your time went up, the longer you drove, the farther you went, correct? Does that make sense? Okay, so if I say Sam varies directly with Tim, then I would say Sam equals K times Tim. Do you understand that? So you have to be able to write this equation. And the reason you have to write this equation is because you have to figure out what the constant is, and so you might apply it to a new problem. All right, let me give you an example. All right, number one. It says if y varies directly as x, and I'll use as this time, and y equals 15 when x equals a negative 5, find y when x equals 7. There's a couple different ways to do this, but what I've kind of found is that I like to find the constant of variation first, and then form the new problem. So if I say y varies directly as x, that means y equals kx. Do you understand that, CJ?
Yeah.
Okay. So as the first information is as x and y equals 15 when x equals a negative 5. So y equals 15 when x equals a negative 5. Given that information, we can now find k. K equals a negative 3, correct? And then we can apply that to our new situation. Find y when x equals 7. Now we know k equals a negative 3 and x equals 7, So my new y is a negative 21, and that is my answer. So you can see how I used k to find the new information. All right? Does that make sense to you? All right. Now, we also have what we call a joint variation. A joint variation. Write that down. A joint variation is when we're varying directly with several variables. Okay? So maybe the problem says this. Suppose y varies. Now we don't always have to use x and y. You understand that. That's why I did the Sam and Tim thing. Suppose y varies jointly as x and z. Okay? Now right off the bat, I can say then y equals kxz. You understand that? Now I have two numbers with it. Then it says find y when x equals 9 and z equals 2 if, that's a 2 by the way, if y equals 20 when z equals 3 and x equals 5. My first question to you is, what do I put in first? That's right. This is turned around, isn't it? We actually put in this information first, right? Whereas up here we put in this information and then this information. Down here we put in this information first. So y equals 20 and k is unknown, z equals 3 and that equals 5. So what I get is 15k equals 20. Dividing by 15, I get k equals what?
3/4.
How about
No.
4/3?
Oh. Yeah, 1 1/3.
Okay, 1 1/3, right? Okay, so now we can use it to find this information. So find y when x equals 9. So we now know that k is 4/3 times, I'm going to put x 9 over 1 because this is a fraction, and z is 2 over 1. Is that correct? And then I can cross cancel if I can. And if you look here, I can cross cancel the 3 and the 9. So I have 4 times 3, which is 12, times 2, which is 24. All right? Now, both of these situations are varies directly. Do you understand that? Well, it turns out that you can have varies inversely. Okay? And here's an interesting fact. I used to give an example of Swan's ice cream. You know, the Swan's truck that goes around. And I used to say, you know, it's like Swan's ice cream. When the temperatures go up in the summer, the sale of ice cream go down. And I told the Swan's guy that. I said, you know, this is what I said. And he said, that's actually not true. They are inversely related. As the temperatures go up, the sales of ice cream actually go down. Explain that to me. You can't. I was just like you. I was like, what? And he said, because people in the summer, they go places, and so they buy less ice cream. And I didn't realize that. So what we're talking about is an inverse relationship, which we call an inverse variation. So as one number goes up, the other number goes down. But we still have a constant of variation. So if I say y varies inversely with x, then I say y equals k over x. And it's a fraction. Okay? It's a fraction.
Will it always be a fraction?
Yes, if it's inversely. Because as x gets larger, y gets smaller. Okay? All right? It's like if I always think of a hot air balloon. As altitude raises, temperature lowers when you go up in a hot air balloon. Okay? All right, so let's take a look at this. I am number 3. Is that correct? If A varies inversely. Now we're using different variables, but we could have used x and y also as B. And A equals 28 when B equals a negative 2. Find A when B equals a negative 10. Okay. So since we know that you got to be able to write your equation first. If it varies directly, it's y equals kx, and if it varies inversely, it's y equals k over x. So we know it's inversely. So we say, in this case, A equals k over b. So we have 28 equals k over a negative 2, multiplying both sides by a negative 2. We get
56.
negative 56, right? And then we can substitute that in, and we can find A when k equals negative 56 over B, in this case is a negative 10, and that would be 5.6. Is that true? Okay. Or 5 3/5, whatever. All right? Now, we have this thing called a combined variation, which is exactly what it says. We have several different kinds of variation. So I say this. Suppose F varies directly as G and varies inversely as H. Find G when F equals 18 and H equals a negative 3 if G equals 24 when H equals 2 and F equals 6. Okay, once again, we use the back information right here to start, but I need to get an equation. I say F varies directly as G and varies inversely as H. So we got to do those two things. So it would be F equals K times G over H. That makes sense, Bo? So I would use this information that F equals 6 when, and I don't know K, that's what I'm trying to find, the constant of variation. And G is varies directly as G. So G is 24 and H is 2. I use this information and I got to find K, right? So I'm going to multiply both sides by 2, correct? 2's cancel, so I get 24K equals 12. So what's K equal? 1/2, right? That might be easier to write 0.5. We'll see here. So now we want to find G. We want to find G, not F. This is different. F is 18. Okay, this is a different type of problem. I'm gonna use 0.5 times g, which is, we don't know, right? Over h, which is a -3, and I'm just doing this information right here. Josh, you understand that? So now I'm gonna multiply both sides by what? -3. And I get a -54 equals 0.5 g, and I'm going to divide both sides by 0.5. What do I get? -108 for g. Okay? Does that kind of make sense to you? Okay. That's the type of problems that you're going to be doing. You just have to read what is varying directly and what is varying inversely. Okay? We're gonna do 7 through 15, and then 19 through 24. Let's take a look at 21 here. We're also gonna do 28 and 30. So let's take a look at 21.
28 through 30.
Yeah, I'll write it down here in a minute. 7 through 15, 19 through 24, 28 through 30. Okay. 21 says community service. Every year, students at West High School collect canned goods for a local food pantry. The plan to distribute flyers to homes in the community asking for donations. They plan to distribute. Last year, 12 students were able to distribute 1,000 flyers in 4 hours. Write an equation that relates the number of students as to the amount of time it takes to distribute 1,000 flyers. Okay. All right. How do we do that? It says write an equation that relates the number of students. So we want students equal to something.
12 students.
They were able to distribute 1,000.
Then K is 100.
S equals 1,000.
Okay.
Or that's what I meant.
Okay, let's take a look at that. Last year, 12 students were able to distribute 1,000 flyers in 4 hours. Okay, so we want to look at what they. Okay, this is kind of difficult, but the 12 students, right? How long did it take them to do it?
4 hours.
4 hours. All right. So my rate is 4 times 12. Is that related? That would be 48, correct? All right. Over, and they say time. Tell me why.
That's a variable.
Because you're trying to figure out.
What does T stand for? Time. What does S stand for?
Students.
So how is the students, because this means that the
Inversely.
students are inversely related, right?
How, it wants to know how many students it's.
Because the more
The more students, less
less
time.
time.
All right.
Students to deliver 1,000.
Listen to what they said. The more students it takes, the less time, so they're inversely related. Okay? The more people we have, it should take less time. Okay, so they're inversely related. Now it says, how long would it take 15 students to hand out the same number of flyers this year? Where does 15 go? It goes into the S, correct? And so I would do this, correct? Now, my question is, how do you solve this?
Multiply by
T.
Divide by 15.
Multiply by T, so I'd have 15T equals,
48.
and then I would take divided by 15, T equals what?
3.2.
3.2 hours. Okay? All right, so once you try this, a lot of them are pretty just straightforward. 22 will rack your brain a little bit, okay? We have tomorrow to work on this, so you might have to.
I heard stuff like this at flight practice.
Yes,
It takes how many miles?
Yes.
How many hours?
yep,
Stuff like that.
it's a very practical thing. We're page 504, we're doing numbers 7 through 15. What are you, okay, thank you, Josh. 7 through 15, 19 through 24, comma, 28 through 30. It is due Monday, okay? It is due Monday. You get a lot of it done today, though. Okay?